A very good afternoon to all of you. So, here I welcome you to the power systems, the first undergraduate course on power systems, and how we have to study it, what benefits we are going to draw from it. Okay. So, basically, before beginning this lecture, I would like to emphasize one thing, as I had also explained to you this thing in the classroom, that power system is a subject that will involve all the essential knowledge. Yes, all the essential knowledge of circuit theory, electromagnetic field theory, and power electronics. Yes, because I understand this thing that many people say that sir, how power electronics is essential in our case of power systems. But I would like to shed light. I would like to shed some light that yes, without power electronics, you won't be able to understand the harmonics part. Okay, and as I had already explained in the class, that harmonics part plays a very important role in the calculation of power. Okay, now coming back to the topic at our hand. So basically, in the first unit, we have to understand that how the power systems developed, how the evolution of power system happened. Okay, so it's a very beautiful story, and it started from the USA. Okay, so you can understand that it was in 1878 when Mr. Thomas Alva Edison, a pioneer scientist, okay, began his work on the electrical lights. Okay, and he basically discovered the DC power. So at Pearl Road, he illuminated the entire area with DC generators. Okay, and the brilliant lighting which he provided at 30 kilowatts and 110 volts to all the 60 customers literally opened the way of electricity for mankind. Okay, after that, the other researchers started their work, and they decided that they will move from direct current to alternating current. The basic structure of Edison's DC generator remained intact. Okay, only the windings changed. Okay, so this is a very beautiful graph through which we can understand this thing, that Thomas Alva Edison in 1882 opened the Pearl substation in New York City. This is how the evolution happened, and I am still wondering that what we people were doing at this instant of time. Now coming back to another very important discovery, that is water wheel driven DC generator. So basically, water wheel driven means that the turbine was used, a structure which literally replicated a turbine was used in a prime mover. Okay, and it was installed in Appleton, Wisconsin. Okay, is it clear? So you can understand that basically the origins of electricity lied at America, United States of America. Now, after that, the first transmission line, you can see that so you can see that how the scientists work. They work in tandem. They work in togetherness. The first transmission lines were installed in Germany, which were working at 2.4 kV DC. So you can understand that today we are using 33 kV, okay, 11 kVs, okay. But when the origin was there, when the start was there, then the transmission lines that were installed in Germany were operating at 2.4 kVs, functioning in on DC, and were having a length of 59 kilometers. Is it clear? Yes, it's quite clear. After that, Frank J. Sprague produced the DC motor, okay, for Edison systems, and it is quite visible. So the impact of Edison is quite visible, that Mr. Frank J. Sprague provided the DC motors for Edison systems. So and the name of the motor was Sprague motors. So basically Sprague motors were DC machines, and it was basically a shunt machine, and it was tested by Thomas Alva Edison, okay, and it worked well. After that, in 1885/6, the development of a transformer happened. It means that the migration, you can understand this thing. This is a very, very beautiful concept, a very beautiful and very important concept, that the revolution, the electrical revolution, basically started in 1882. Okay, clear? And it culminated, or you can say that a major breakthrough was obtained just after 4 years. So this was the way in which the scientists worked. In 4 years, a commercially practical transformer was developed. It means that William Stanley, Thomas Alva Edison, Frank J. Sprague, all were working in tandem. Yes, all were working in collaboration with each other, so that the development in electricity can happen. Is that clear? I think it's quite clear. Then the man of the hour. Yes, I am a big fan of this man. This man arrived in 1888 and changed the entire course of research. Yes, he changed the entire part. It was in 1888 that papers on two-phase AC induction, look very carefully, this is two-phase AC induction and synchronous motors. It's not three-phase, it's two-phase. So I think this point should be very much clear, that it's two-phase machines, not three-phase machines. Okay. So I would like to emphasize, I would like to revise this part, that evolution started in 1882. After that, by respected Thomas Alva Edison. After that, a generator was installed in Appleton in the same year, and it was a DC generator. And DC transmission line were made functional in Germany. After that, Sprague motors were developed. Stanley developed a transformer, and Tesla appeared on the picture. So more about this evolution we will discuss in the next class. Thank you and have a fantastic day.